Hello students, this video is about radical functions and today we're going to be focusing on graphing them. Now the first thing I'd like you to know about these is that radical functions are the inverse of quadratics that we've already been studying. So quadratic functions and square roots are inverses. So what I mean by the fact that they're inverses is that one function undoes the other. You can tell that graphs are inverses of each other because if you were to take the blue graph and reflect it over the line that I just drew, y equals x, you would get the pink graph. So this graph is today's function, it's the square root function. Now, the way that I have it drawn right now though, the graph of the square root of x is not actually a function, is it? Why is it not a function? Because it fails the vertical line test. Okay, in order to be a function, it can only cross the vertical line once, and here it crosses twice. So actually, this would not be a function the way I have it drawn. How we fix that problem is that when we graph this, we restrict the range to only look at the positive values here. So we're only going to be graphing the top arc. Okay? This is the graph that we're going to be doing for today, and that is the graph of the square root. So let's talk about a couple more properties of that graph. Okay, so for the parent function f of x equals square root of x, which I have graphed right here, we can see that the domain, what x values are covered? Well, the x values that are used, here's my x-axis, the x values are only these x values here, okay? Only the positive x values. So my domain is all positive numbers for x. And as far as my range, what y values are covered? Well, on my y-axis, this graph only covers from here going up. So, and it would go up higher and higher as this went out farther and farther and farther, right? Okay, so the range is also going to be positive y values, y is greater than 0. And then when we're graphing these, and when you're actually doing the work of these problems, I'd like you to take these 4 points and move them around. So these are going to be some points that are going to be easy for us to use on the graph. We have the point 0, 0. The graph goes through the point 1, 1, okay? And it goes through the point 4, 1, 2, 3, 4, up 2. And the graph also goes through the point 9, 3. 9, the square root of 9 being 3. So I'm going to keep those points in mind as we continue further with our work. Now, what you need to know about the transformations of this graph. I'm going to give you the general formula for the transformations of the original parent function. Okay, so now we are coming to the main important part for today's lesson, and that is transformations of the original parent function. So, just like we had these transformations that happen to quadratics, well, the same kind of thing is happening to square roots now. So, here is a general formula for all the different things that can happen to. So let's go through these one by one. They are pretty much the same as the quadratics, okay? For example, the A. The A in front is the vertical stretch or compression. Okay? So the A is going to make the vertical being y, it's going to multiply the y value by something. Okay? The B does the same thing for the x values. So the B is a horizontal. Now, notice when you're looking at the B, how the x values are opposite of what you would expect. Like in here, remember how the h, it has a minus h, it's a negative h in the formula, but that would be, you would think that this h down here is positive. So if you have an x minus 3, it actually moves it in a positive 3 direction. All right, so same thing with the b. Instead of just being times b, it's 1 over b. Okay, so it's the opposite of what you would expect. Okay, and now the h is a horizontal shift, and the k is the vertical shift. Okay, so I'd like to point out to you that the b and the h have to do with the x values, while the a and the k have to do with the y values. So The b and the h have to do with the x values, and the a and the k have to do with the y values. We're talking about vertical. Okay, so let's look at an example. I have 3 examples for us of this type of problem. And before I move on to those examples, let me just say also what happens if you have a negative a. If you have a negative a value, okay, if the number in front is negative, that's a reflection. And it reflects over the line y equals 0. So here's my y-axis. Here's where y is equal to 0 at. Okay? So if I put a line here and reflect the graph over that line, okay, that is what happens if the a value is equal to 0. If the b value, the value on the inside, is equal to 0, that's also a reflection. But this time it's going to reflect over x equals 0. So here's my x-axis. The x-axis is equal to 0 right here. Okay? So if I take and draw a line through that and reflect over it, okay, then that's what happens if the b value is equal to 0. So if you have a negative a or b, that is a reflection of the graph. So now we have covered all the various scenarios that happen with this equation. Now let's look at some examples. In this first example, we're asked to graph this function g of x. So let's take this g of x and look at it and compare it to our original parent function to see how it's changed. Okay, I see 2 things that we needed to deal with. One, it's been multiplied by 2 out front, and secondly, we have a 3 added on the inside of the square root. So this 2 is in the place of where the a value would be. It looks like we have an a value of 2. Well, if you look back, the a, that means we have a vertical stretch of 2. What this is going to be is it's going to change the y values. So this is going to multiply all of our y values by 2. Now, what about the 3 on the inside that's been added here? Well, this 3 is a horizontal shift of 3. And because it has a positive in here, the x values are actually opposite. I need to go negative 3. I need to left 3. So this is going to take all of my x values and it's going to subtract 3. It's going to move all my x values 3 to the left. So as I get ready to graph this, I'm going to graph both my function that I want to graph as well as my original parent function. So I'm going to graph my original function. There are 4 points from my original function that I'm going to graph. 0, 0, 1, 1, 4, 2, and 9, 3. And I want you to use those same 4 original points every time we get to graph. So use those points. I'm going to go ahead and graph them on my graph. 0, 0, 1, 1, 4, 2. And I'm not going to graph 9, 3 because I don't have enough room. Let's see what happens to those original points as I do a vertical stretch of 2 and a horizontal shift of 3. So now, to make my new function, I'm going to take all of my x values and I'm going to subtract 3 from them. And I'm going to take all of my y values and I'm going to multiply them by 2. So my first point, 0, 0. 0 minus 3 is negative 3. That's my x value. Now my y value, I have to multiply by 2 for my vertical stretch. 0 times 2 is 0. Okay, for the next point, I take my x value and I subtract 3. 1 minus 3 is negative 2. And then to find my y value, multiply by 2. 1 times 2 is 2. 4 minus 3 gives me 1. 2 times 2 is 4. And let's go ahead and see 9. I don't know if it's going to fit on my graph or not. 9 minus 3. 9 minus 3 is 6. 3 times 2 is 6. And 6 gives us this point. So here is our graph of g of x. Second example. Okay, next example. Now let's see if we can graph this function g of x. Okay, so I'm looking at this function and I'm comparing it to my original to see how it's changed. And I see 2 things that are different. One, there's a negative in front of this x on the inside. And second, I have a minus 2 on the very end. Well, the negative in the inside, that's where my b value would go on this. So it looks like I have a negative b. Well, a negative b is going to be a reflection over x equals 0. And a minus 2 is going to be a vertical shift of 2. So when I'm looking at my actual points, a reflection over x equals 0, that's going to make all of my x values negative. A shift of 2 is going to subtract 2 from all of my y values. Okay, so let's graph the original. We see that it's 0, 0, 1, 1, 4, 2, and 9, 3. Okay, now what happens to each of these points when we take each x value and make it negative, and take each y value and subtract 2 from it? So let's do this in pink. Make the x value negative. Negative 0 is still 0. Subtract 2 from the y values. 0 minus 2 is negative 2. Take the x value and make it negative. That's negative 1. Take the y value and subtract 2 from it. 1 minus 2 is negative 1. The x value becomes negative. That's negative 4. The y value minus 2. 2 minus 2 is 0. The x value, make it negative. And the y value, subtract 2. That gives us 1. So now I can graph my new function. My new function g of x is going to be graphed in pink. And we're going to have 0, negative 2, and negative 1, negative 1, negative 4, 0, and negative 9, 1. Okay, so here's our new function in pink, and you can see that the function has been shifted down 2. That's from this negative 2 right here, and it's been reflected over the line x equals 0, which is what the negative did right here. Last example. For this last example, 3, let's see if we can write the function g, where the parent function f of x equals square root of x, is stretched horizontally by a factor of 2, reflected across the y-axis, and translated 3 units to the left. So let's see if we can write that equation. Yes, we can. So first of all, the new equation has a horizontal stretch of 2. Okay, if it has a horizontal stretch of 2, then that is the b value. That means that b equals 2. Okay, so now we have a reflection across the y-axis. Okay, so now if we have a reflection over the y-axis, we need to figure out what that is. Over the y-axis, what is the equation of that line? Well, the equation of this line of the y-axis is at the spot where x equals 0. So we have a reflection over the y-axis being the same as x equals 0. That means that the b value, the value in front of the x, is negative. Okay, and lastly, we see that it's translated 3 units to the left. Okay, so moving left and right, that's my x-axis. So it looks like my x value it needs to be moved. Let's see, that's going to be my h, right? So 3 units to the left, that is going to mean that h is equaling 3. Since the h value is negative, since the h value is moving to the left, that means we want our h to be negative 3. So now I'm going to plug into my formula. When I plug into my formula, now they want me to call it g, so I'm going to call it g of x equals, they don't tell me anything about an a, so I don't need to worry about a number in front. The inside value is b, and it needs to be 2, and we need to have a negative b. So negative 2. Oh. And actually, according to the formula, we have 1 over b. So 1 over negative 2. Okay. X minus h, and h is negative 3. So that's what we have here. Now, Think back to that formula. There was no value for A, so we did not have a number in front. And there was no value that we needed for K, so there was no value on the end either. So we just followed that same formula for transformations of these. So that means that this is our answer. The only thing I really want to change is change that minus into a plus. And that is the equation. Good job.